So on your notes, we've got some graphing in ordered pairs up in here. And this is the coordinate system. The coordinate system is just this grid. Some people like to be fancy and call it the Cartesian coordinate system. But that sounds really nerdy. Unless you play the first Halo, then it sounds really sweet, right? Because they have the thing called the cartographer.
No, you sound nerdy.
Oh, the Kotar.
That's because I am a nerd. So that makes sense.
He's a math teacher.
Well, that's what this is, the coordinate system. The Cartesian coordinate system as well. It's a grid created when the x and the y axis cross at 0. Not just any 0 though.
Origin 0.
0, 0, 0. Alright, so what you may see, especially on notes or homeworks, is they're not going to show a dot right yonder, but they may draw a circle right here. That is not a number, but you will think that it is. It's not a number, it is the letter O, which is short for origin. That's why it's called the origin. That's where it is. Well, if it were a 0, then we'd need 2 zeros, and that's a lot more work than we really want to do, right?
Yeah.
So it is a O, not a 0. All right, then next up we got the x-axis right here. It's the horizontal axis. On papers and stuff, it'll be just labeled with an X right here. Of course, it's got arrows going to the left and the right. If we had nothing else on this paper but the x-axis, it would remind you, hopefully, of a number line. That's because it is a number line. Here is 0, 1, 2, 3, and 4. But it also goes to the left of 0, which are the negative numbers. Yes. Then we've got the y-axis, which is this vertical axis up in here. Now this one right here is also a number line, but it's vertical.
That's the word.
Yeah. You probably did, but it's nice to review, right? And starting at 0, which is at the origin, which we stated already, you go up to 1, 2, 3, 4. It goes up as far as we need it to go. Sometimes we have to change the scale, so each line may represent something like a 2 instead of 1. Then you got 2, 4, 6, 8. If you do that, if you decide to change the scale, then you have to change it consistently throughout. You can't go by 1, and then 3, and then 7, and then 2. You see what I'm saying? That would be really, really weird. Then you are dealing with something not the Cartesian coordinate system, and you will lose points on a test. Fortunately for us, though, we're just dealing with ones, and that makes it really pretty. Well, the origin we already talked about up in here. It's where the two axes meet, because the y is 0, and the x is 0. An ordered pair. An ordered pair is in the form of these. You get some parentheses up in here. And you're going to have what they call an x value. That is the value of x on the x-axis. So if we look down here at A, the x right here is 2. So where is 2? Where is 2 on the x-axis? Bam. But it's all along this line up in here, like these. Well, then we look at the next value, which is the y value. You can fit that in there. The y value right here is -3. So on the number line, which is the y-axis, I need to find -3. Bam, I found it. -3, y is -3 all along this line. And we just need to find out where those two dotted lines meet. Found it. Found it. It's right there. And that we would label point A, which is this point right here. We don't need that purple stuff anymore. Moving around with the coordinate system. So if we look up here to this -5, 3. -5, 3. Well, one way to look at this is that negative 5 means 5 to the left. So always starting at the origin, you'd go 5 to the left, and then 3 means 3 up. Not like extra lives in Mario Brothers, though. So you go up 3, and bam! There's our value, the point, negative 5, 3, there in the orange. So, and that's what this is saying up, yeah, this stuff. It's saying your x value is going to tell you either go to the left or the right, depending on if it's positive or negative, or up or down on the y, depending on if it's positive or negative, respectively. So to make things more lovable for people, this coordinate system, what they've done is they made quadrants, because see how it's kind of split up by the axis into, quadrants. That's what that is, quadrants. We got quadrant 1, which is in the top right, because that's where you always would start, like if you're reading or something in Japanese. So we start up here, up in count. And, since everything is backwards out in some of those Asian countries, they went counterclockwise, right?
They go down.
Yeah.
They start on the left.
Well, yeah.
No, they start on the right. They're down.
Yeah, so this is kind of the same thing. It's just a little different. What we're going to do, because you guys want to go clockwise, right? That'd be really lame and very normal.
In America, you go down.
So, what we're going to do, we're going to start in quadrant 1. So quadrant 2 is counterclockwise, right here. And then quadrant 3 is down here. No, here. And quadrant 4. So, this is very nice because this examples that they've given you. See, in quadrant 1, those values. That's telling us that all the x values are positive. Why? Because, see, this is a number line. All the positive values are to the right of the origin. Not only that, but all the values in quadrant 1 are upwards from the origin, which is why the y value is also always going to be positive in the quadrant 1. And then we could use the same reasoning for all the others. So, they've given us some values to consider, and we're going to figure out which quadrant these points be in. Such as negative 13, 17. Well, that would be to the left and then upwards, putting us in quadrant 2. Yeah, very nice. You see that? Oh yeah, unfortunately, the Romans thought this was super awesome, so now you have to write them in Roman numerals as well.
Awesome. Run it in cool.
Yes, that would be fine also. Yes.
How big can they get?
What?
How big can the beans get?
Roman numerals?
The scale will determine how big the number lines will be. I mean, you could use a small one like this, and based on a scale, we could say, well, this value right here is 100,000. Just depends on the scale. Yeah, if you wanted to, you could write Q2, so it's a quadrant 2. All right, what about the next one? Well, that's a positive 21, so that'd be to the right, and then upwards to 23. Bam, quadrant of 1. And then the next one, 11, negative 32. Which one is that?
11. 4. It's quadrant 4. 11 is in
4. Very good. What about negative 14, negative 2?
That's quadrant 3.
3. Nice. What about negative 8, 12?
That's 2.
2. What about negative 9, negative 12?
That's quadrant 3.
3, very nice. What about negative 4, negative 1?
3, 4.
3, very good. What about 54, 49er?
1.
Look, 1.
1.
And finally, what about 4, 0?
1.
Both. It's 1 and 4.
Ooh, it's
All right, as it turns out, it is not in quadrant 1, but it is also not in quadrant Fjord.
So it's on number
It's on the origin.
This one is on the x-axis. There it
Wait, did
is.
you say the x origin?
No, because the origin is just the origin, 0, 0.
If it's
Oh yeah,
0,
'cause that's 0, 0.
Yeah, this one would be on the x-axis. I mean, you know, depending on your scale, maybe about right account.
Okay, so but if it was 0, like 2 would be on the y-axis.
What do you guys think? If that was 0, 2, where would that be?
Yes, it'd be up.
Y-axis.
It would be on the y-axis. Yes,
Wait, if it's 0, 0, do you just say origin?
Yeah.
that is correct. So the last one, the unique, would be 0, 0, which would be the origin. So the nice thing about this is if you do these in order, they will spell something very, very nice. Very nice message which will make you feel good inside. So, 1, which is -5 faux. So again, I need to find -5, which is right here on the x-axis. Faux, which is up here. So we can see that these two are coming together at the point A. There we go. Oh, no, it does. You'll see. You may have spelt it wrong. It's okay. Number 2 is at 3 Juan.
L.
Let me get rid of these lines real quick.
L.
It is L. Very nice. So,
How can ALQ spelling?
well, it's not. It's a message. It's not all just one word. It's a nice message, which you know should cause delight in your heart. All right, 3, 5. 3, 5. Bam. Looks like it is Q. What about Fjord is 4, 1? So there's 4 up 1. Bam. That is P. Very nice. Next one, 2, -3. X. Bam.
What's number 6?
And now that's 6. -2, there's -2. And then up 2, bam. H.
I thought it was.
So this message is an acronym for whatever you need it to stand for so that it gives you good feelings and fuzzies in your heart. Okay.
I worked hard for that, but I'm getting
Yeah, well, make sure none of those stand for any swear words. That would be bad. Should only stand for good words such as happiness and altruism. I don't know if that's a good thing or bad thing. All right. Okay, someone tell me the coordinates of G. -4 Juan. Very good. It will tell us the coordinates for R. 1 Fjord. Very nice. What about V?
-3, -4.
-4, -4?
-3.
-3, -4? Oh, my bad. Okay, we're good. All right, what about B?
0, -4.
0, 4? -4. Okay, all right. What about M?
-2,
-2, -1. And finally, F.
5,
5, -4. All right, 13 through 21, we're going to graph these. 19 through 21, we're going to state the quadrant that those be in. So C, let's start with C up in a here. 2, 4, so X is 2, Y is 4, bam, there's my point. And I do need to label these. If you do not label them on a test, it would be marked incorrect. N, -1 to 3 is at these. And then I label it N. 15, -3, 5, bam. There it is, V.
What if you don't label them? Will you lose points?
Yes.
Only on a test. And yes. 16, 5, 1. There it is. I found it. M.
This is so easy.
Yes! I'm glad someone caught that. Someone's paying attention.
I was doing
That was in the wrong place on purpose. So 5 of 1, we got to do the x's first. There's our 5, and then a 1, bam. There is the actual m. Come on!
Even looking at
Now, I know, okay, that's fine. But just so you guys understand, that is a common mistake. It's not that you don't know how to do it, it's just that in your mind sometimes you do it backwards. Don't do it backwards, because the x's come first, which is kind of convenient because it's actually in alphabetical order. X, Y, and then Z, you know what I'm saying? It's pretty sweet, right? What about B? 2, -4. Right here.
You can erase the dark spots on your paper.
B. No, I did. It's gone. I erased it right there.
But look.
What about L? -1, -4. Right here. There's good old L. Well, finally, then we got this. Draw a triangle at faux. Right here. And what quadrant is this? This is quadrant 1. And then we got a cycle at -2, 5. -2, 5, a cycle right here. And that right there is quadrant 2. What about 1, -4? Right here. Cycle. Oh, I did that. Hold on a second. I don't know what the heck happened there. 1, -4. There it is. Bam, that's a perfect square. And that right there is in quadrant